Hello and welcome to your video lesson. This is page 14 of the packet. Please go get to page 14. All right, hopefully you're on page 14 in Notability. I'm going to be asking you guys to pause the video and try the problems one at a time. When you're ready to review that problem, unpause the video and watch to see my solution. So let's start with problem 1. Pause the video, go try problem 1 on 14, and come back to the video when you're ready to see my solution. All right, hopefully you are ready to see my solution and you have completely solved problem 1. So the first thing that I want to do is find the key word that tells me if I'm finding GCF or LCM. What I found was greatest. Greatest is right in the problem. That tells me that this is a GCF problem. It does have 3 numbers. For 3 numbers, you do all 3 numbers together if it's GCF. So 36, 48, and 72. For LCM, that's the one where we have to break up the 3 numbers. So I like to start with my 2's. Maybe I'll start by dividing everything by 2. You might have chosen something else, but hopefully we'll get the same answer in the end. 36 divided by 2 is 18. 48 divided by 2 is 24. 72 divided by 2 is 36. All right, next layer. They still have common factors. I think I'm going to do 6 on this one. 18 divided by 6 is 3. 24 divided by 6 is 4. 36 divided by 6 is 6. On this last layer of the cake, they have nothing in common. GCF is the frosting down the side of the cake. So 2 times 6 times 1 is 12. Even if you did the cake differently, hopefully you still got 12 as the correct answer. So Ed can divide the jelly beans evenly among 12 friends. In fact, you can even use the bottom of the cake to see that each friend would get 3 red jelly beans, 4 blue jelly beans, and 6 yellow jelly beans. Neat trick at the end of that. Try number 2. Pause the video, go try your number 2, then come back to see my solution. All right, hopefully you're ready to see how I did the problem and compare it to yours. First thing I want to do is find the key word. This does not have a clear key word. And usually if you can't find an obvious word, it's an LCM problem. And the key word here would be like first to receive both. When will they meet again? That sort of problem. So there's only 2 numbers, so we can do both of those numbers, 12 and 20 together. This is LCM. 12 and 20, I could divide them both by 2. That gets me 6 and 10. I could divide them by 2 again. That gets me 3 and 5. 3 and 5 don't have anything in common except 1. For LCM, I'm using the L-shaped frosting, extra hungry. So 2 times 2 times 1 times 3 times 5. You might do 2 times 2 first, which is 4, and then 3 times 5 next, which is 15, and then 4 times 15 is 60. One thing I forgot to do in my first problem is units. So sorry about that. 12 friends, and then this problem would be 60th caller. So 60th caller. I'm going to shrink the work a little bit just so we can see it all at once. So every 12th caller receives the CD. Every 20th caller receives 4 free tickets. The 60th caller is going to get both prizes. Lucky them. Next problem. Pause the video. Try number 3 on your iPad. Come back and watch the video when you're ready to see my solution. All right, so we have that the hamburger buns are sold in packages of 8, the patties are sold in packages of 6, and we want to serve 24 people. So this one is kind of a different type of problem. I don't even have to do a cake for this. If I need to serve 24 people, and the buns are in packages of 8. So buns are in packages of 8. Patties are in packages of 6. All we have to do is divide. So 24 people divided by packages of 8, this is for the buns, means I need 3 packages of buns. Same thing, 24 people divided by packages of 6, this is for the patties, means 4 packages of patties. So they kind of gave us the LCM in this problem, and they just wanted to know how to apply that. So this answer would be choice D. Different type of problem. All right, lastly, we have problem 4. Please pause the video and try problem 4 on your own. Come back when you're ready to go over it. All right, hopefully you've tried problem 4 and you're ready to go over the solution. So the first thing we need to do is determine what type of problem this is. And again, it doesn't really say anything to do with like greatest or least, but what locker will be the first to have all 3? That's like a meet again type problem, which will have everything, which will have both, meet again. Those are all words that go with LCM. So this is going to be an LCM problem. And I do notice there's 3 numbers in there. There's 4, 6, and 9. They're putting a star on every 4th locker, an orange star in every 4th locker, a white star in every 6th locker, and the 9th locker gets an eagle. So LCM of all 3 numbers. When you do LCM of 3 numbers, you pick 2 numbers to start with, any 2. I usually just pick with whatever I see first, so 4 and 6. So first we need to find the LCM of 4 and 6 only, and we're ignoring the 9 for now. I could divide them both by 2. That gets me 2 and 3. 2 and 3 don't have any more common factors. I do the L-shaped frosting here. 2 times 2 times 3 is 4 times 3, which is 12. Now I take that 12 along with the number I haven't used yet and find the LCM of those 2 numbers. So 12 and 9. This one's going to be my final answer. I could divide them both by 3. That gives me 4 and 3. 4 and 3 don't have any common factors, so just 1. I'm done with this one. Find the LCM of 12 and 9 by multiplying the L-shaped frosting. 3 times 1 times 4 times 3. That's going to be 12 times 3, which is 36. And my unit is going to be the 36th locker. And that's my final answer. All right, hope you learned something, or hope at least you got to practice a little more LCM and GCF type of problems. Thanks for watching.